Address Resolution Protocol, ARP. Two types of addressing are used to identify network hosts, the IP or Layer 3 address and the local or data link layer address. The data link layer address is also commonly referred to as the MAC address. Address resolution, as defined in RFC 826, is the process in which the iOS determines the data link layer address from the network layer or IP address. ARP resolves a known IP address to a MAC address. When a host needs to transfer data across the network, it needs to know the other host's MAC address. The host checks its ARP cache, and if the MAC address is not there, it sends out an ARP broadcast message to find the other host's MAC address. An ARP entry is required for communication across the network. You can see that a broadcast has taken place if there is no ARP entry. It is also important to understand that ARP tables on routers and switches are flushed after a certain amount of time, for hours by default, to conserve resources and prevent inaccurate entries. ARP cache. After receiving the MAC address, ARP passes it to the sender where it is stored in a table for future reference. And this is called ARP cache, which is later used to obtain the MAC address. ARP cache timeout. This is the time in which the MAC address can remain in the ARP cache. ARP request. Broadcasting a packet over the network to verify whether we have arrived at the destination MAC address. ARP response/reply. It is a MAC address response that the sender receives from the receiver, which helps in further communication of data. Types of ARP. There are 4 types of ARP protocol. They are as follows. 1. Proxy ARP. 2. Gratuitous ARP. 3. Reverse ARP. 4. Inverse ARP. Proxy ARP. This is a technique through which proxy ARP in a network can answer ARP queries of IP addresses that are not in that network. That is, if we understand it in simple language, the proxy server can also respond to queries of IP address of other networks. Proxy ARP is defined in RFC 1027. Proxy ARP enables hosts on an Ethernet network to communicate with hosts on other subnets or networks, even though they have no knowledge of routing. If an ARP broadcast reaches a router, it will not forward it, by default. Routers do not forward broadcasts, but if they do know how to find the host, i.e., they have a route to it, they will send their own MAC address to the host. This process is called proxy ARP, and it allows the host to send the data thinking it is going straight to the remote host. The router swaps the MAC address and then forwards the packet to the correct next hop. Through this, we can fool the other person because instead of the MAC address of the destination device, the MAC address of the proxy server or router is used and the other person does not even know. Gratuitous ARP. This is an ARP request of a host, which we use to check duplicate IP address. And we can also use it to update the ARP table of other devices. That is, through this, we can check whether the host is using its original IP address, or is using a duplicate IP address. GARP is a special ARP packet. A normal host will always send out a GARP request after the link goes up or the interface is enabled. Gratuitous in this case means a request/reply that is not normally needed according to the ARP RFC specification, but could be used in some cases. A gratuitous ARP request is an ARP request packet where the source MAC, the source IP, and the destination IP addresses are all set to the IP address of the machine issuing the packet, and the destination MAC is the broadcast address FFFF. Ordinarily, no reply packet will occur. A GARP reply is one to which no request has been made. If you see a GARP reply, that means another computer on the network has the same IP address as you have. This is a very important ARP, which proves to be very helpful in protecting us from the wrong person, and by using it, we can check the IP address. Reverse ARP. RARP maps a known MAC address to an IP address. Hosts such as diskless workstations, also known as thin clients, know their MAC address when they boot. They use RARP to discover their IP address from a DHCP server on the network. That is, to know the IP address of our computer server, we use reverse ARP, which works under a networking protocol. It is a TCP/IP protocol, which we use to obtain information about the IP address of the computer server. Inverse ARP, in ARP. Inverse ARP, it is the opposite of ARP, that is, we use it to know the IP address of our device through MAC address, that is, it is such a networking technology, through this we convert MAC address into IP address. Can translate. It is mainly used in ATM machines. Advantages of ARP protocol. There are many advantages of ARP protocol. Some important advantages are: by using this protocol, we can easily find out the MAC address of the device. There is no need to configure the end nodes at all to extract the MAC address through this protocol. Through this protocol, we can easily translate IP address into MAC address. There are 4 main types of this protocol, which we can use in different ways, and they prove to be very helpful. Thanks for watching and stay connected for all upcoming videos.